We'll be talking about document-oriented database. And first thing I want is you tell me, what do you know about databases? Somebody shoot, please. Christina, tell me, what do you know about databases?
Nothing.
You don't know anything about databases. Have you done anything about databases in this course yet?
Yes.
What have you done?
I don't remember.
You don't remember, okay. What about you, Ricardo?
I'm good with the subject and the document databases part, so I'll pass it to somebody else.
Okay.
We covered SQL on Monday, so we already covered that part. That the document-oriented database is the new part for the rest.
Okay. How do you feel about it, Thomas? What do you know about databases? If I tell you a database, what is it?
We did cover MySQL on Monday, and what was the other one we covered on Monday? So we covered two, right? We covered, I think it was MySQL. I don't remember what the other one was, but
no, it was all about SQL-based databases. So MySQL is what leads the market on regards to the open source, unless you go to a corporate world and you might find something else like Microsoft SQL or something. But generally speaking, what we did, what might have confused you, Thomas, is that we also covered about the ORMs, and that's where the SQLites get into the picture, because it's an ORM. But basically, those were SQL-based databases, and what we talked that we were going to be covering today, it's MongoDB, which is a document-based database. It's not, it doesn't work the same as the traditional SQL databases. So
right. So I heard a couple of things in here. So obviously you covered SQL. So first things first, what you covered is relational databases, right? So there is a relationship between data that is somehow established. So that's SQL. MySQL is just one branch, as Ricardo says, just one branch, one kind of software of SQL. There is also PostgreSQL, there is MS SQL, and other SQL servers. The next thing that I heard was ORM. ORM is a software layer between your application and the SQL database. Okay, this is very important to understand. It's not something that would be in the database. So you can use...
It's a software layer, so it's basically the relationship between your code and the database.
Exactly, but it's in your code, right? So it's just another layer in your code, how to communicate with the database.
So is that Express then?
No, Express is a web server. That's not ORM. ORM is basically a library, and there are different libraries to do ORM, because ORM can have some different shapes as well. It's just library that you install on your project. What you do then is you define your kind of models, your objects, and then it will give you tools to communicate with the database, right? So it's just think about it.
It's like a CLI for your database.
Sorry?
Or is it like a CLI, like a command line interface for your database?
It's in the code. It's actually in the code, right? So you install it, and in the code you will have basically tools now to use to communicate with your database. But it's like an abstraction almost.
Okay.
So instead of you having to manually kind of connect to the server and ensure the server is running and like, you know, do transactional not sure what happens here. Transactional queries and things like that. It will do it it will give you tools to do it more effectively and without like all the background stuff, because there's a lot of stuff that basically is happening. So it's almost like an abstraction. But the kind of main purpose of this is for relation databases is that it will give you the kind of connections between data as well. So for example, if you have one table, and hopefully everybody understands what table is, if you have one table with data and that table is somehow connected to another table with the data, with different data. So for example, if you have a user table, so every user has an ID and name and stuff, and then you have another table which would be, for example, address table, so all the fields of address, house number and so on, then you would have a connection between those, and you would say, well, this address belongs to this user, right? So you would have what we call joined. And ORM ORM systems, they will help you to kind of keep these connections in your code as well. So for example, if you update one side of the whole joint, it will propagate it to the others based on some kind of rules. So it will kind of help you to handle the database rather than doing everything absolutely manually, right?
Got it.
So
it's like if you were comparing to Excel, which is what we use in my world, it's kind of the formulas that you have in the cell.
Yeah, something like that. Yeah. So it's kind of like a software layer. I wouldn't say that it's necessarily only for SQL database or relational databases. You can have it for document-oriented databases as well, but it doesn't work as well for document-oriented databases. The reason why do we have it is just it's a software layer, right? It's not bound to anything. You can create whatever you want in your software. So somebody's thought, well, usually what happens is you have this SQL guys coming over to Mongo, and they want the same kind of handling of SQL in Mongo, so it's familiar for them, so they don't have to worry about what's new in Mongo, like how else to handle your data. So what they do then, they will go create and create these kind of systems, and they will port it into something like Mongo. So you can have it there. It's just a software layer, right? I would say it's probably not a very good idea, because in that sense, even though you are actually using document-oriented database, by implementing this layer in there, you are actually limiting yourself what you can do with the document-oriented database, right? So imagine that you have something, you have something that does something, right? And then you have something else that does similar thing but somehow else, and each of them has some kind of advantages. If you write one common interface between those two to do the same thing, that means you will use the core that they do the same, which is storing data, but all the advantages will go away, right? Because you can't really write the same thing for the same layer, the same interface for two different things, right? So that's why it might not be the best idea, but it's just a software layer, so you can do it basically. When we say database, you should think data storage, right? And even more, you should think persistent data storage, and that's the most important thing in here. So databases are persistent data storage. Doesn't matter if it's document oriented or if it's SQL. You're saving data that is at some point saved to a hard drive. Well, I mean, it should be saved to a hard drive. Let's just say that, and it will persist. So what that means is, if you kill your server, right? If you destroy your server and you create a new one, so if you destroy your application, you create a new one, the data is still there because it was saved in your database. Okay, so it's kind of application agnostic. It's its own server that you save data to, and then you can request the data from anywhere else. Doesn't matter if it's a new application or old application or anything, or something with direct access. It's just something to store persistent data. Non-persistent data examples would be, for example, if you store something in files on the server, or if you store something just in memory. So as your application is running, you just store it in variables and you remember it. That's your non-persistent storage. Because once you kill the application, once you restart the application, all this data is going to be lost, right? Because it was just in your variables. Once you restart it, the whole thing is clean, starting from clean slate. So if you want to persist some data, and in most cases that's what you will want, you will have to use some kind of storage, and for web the most used is a database. So that's database. Does that make sense,
Sorry,
Christina?
if I missed that, but did you explain what the document-oriented database actually is? I understand the relation one, but not the...
I'm getting to it. It's not. I didn't explain to it. Does it make sense, Christina?
Yeah. Now I understand it's storage.
Okay. Cool. Great. So now let's go to document-oriented database. The main difference between document-oriented database from relational databases is that you don't have these relationships between pieces of data, but all the data are basically in one piece. So that's why we call it a document. It's almost like if you imagine you would have your like a Word document, you're basically describing all the data in one big document, right? So instead of having pieces of data scattered along tables and then kind of pulling them all together into one meaningful thing, you just store them in one document. And that's the main difference between relational databases and document-oriented databases. Does that make sense? I don't want to go further if that doesn't make sense.
But is it so? How do you make sense of it then if there is no table? Is there a table in that? Or?
Because you have all the data in that one document that you need, right? So let's just I will try to demonstrate it somehow. So if I open a new browser, I don't know why it opened in here. 1 second. So now, if I actually let's just do this. Try. Right. So now, this is, let's say, my relational database. I don't know why I can't use it. Right. So in here we have user. In here we have address. And actually what you normally do in relational databases, you would have another table in the middle. That would be something like address mapping. So basically what happens is, this is connected here, that is connected there, right? And this is your relational database. You have one table where you store all the users. You have one table where you store all the addresses. And then you have one table in the middle, usually, not necessarily always, but usually, where you store the mapping between the user and the address, right? So this is especially useful if you have multiple addresses, yes, for user. So you would have, in this one, you would literally just have user ID, address ID, and you would have long list of the mapping between those two. And in here you would have all the information about user, in here all the information about address. You could also have, if you have a single address per user, you could have this, and you wouldn't have to have this one in the middle. So you would just have, in user table, you would have address ID, and it would just point to one address. But let's just leave it like this for now, right? So let's say we have multiple addresses, yeah? So now, let me just try to demonstrate it a little bit more. So you would have, actually, let's just show what would be in here, right? So in here, okay, you would have your user ID, and you would have your address ID, and then you would have 3, for example, and then you would have 2, and 1, 5, right? For example, I'm sorry that it doesn't online. I don't know how to do a table in here. So this would be your kind of example of what it looks like inside of this table in the address mapping. So what we're saying is user 1 has 2 addresses. It comes from here, and the address IDs are 3 and 5. Okay, so this is relational database. Now let's go. Sorry?
Yes, right, yes.
Yeah, okay. So now let's go to document-based database. So, and document-based databases are nothing new, by the way. Everybody, when you say that, everybody will straight away tell you Mongo, but actually Mongo might not be the best choice for a lot of projects. So, you know, try to be kind of open-minded about what it is. Same way like relational databases is not necessarily just MySQL, it's others as well. So, you know, Mongo was the one player that went there and did like, you know, they did a lot of noise around it basically, but it's nothing new. It's been there before, and there are others basically. So document-based database, how would this example look like is that you would have one document, and that document would be user. Okay, so let me just put the label in here. So this would be our user. Yeah, and inside of the document, you would have some information about the user, and then inside of it, you would have your addresses. Okay, and inside of those addresses, you would have address 1, actually, what was it? Address 3, and address 5. Okay, but this whole thing is one document. It's the whole entity of the document. Does that make any sense?
Yes, so how can you make the relationship between the user and the address then, in that case?
Well, it's all in one entity. You know that these addresses are belonging to this user because it's inside of the user.
Okay, but if you have multiple users, then how does it work?
If you have multiple users, then you would have multiple users like this.
Ah, okay.
So you would have user 1 that would have all the addresses that it belongs to that user. You would have user 2, and that would have its own addresses, which would be number 2. Okay.
Got it.
Now let me show you the same thing in a script, in a code. I mean, it's not, you know, hopefully you'll understand it, but basically, imagine that we have tables. I mean, I will try to represent it by JSON. Okay. So imagine that we have our relational database. Okay. In there we have table users, and inside of the table we would have ID 1, name, Thomas, and then you would have addresses. No, you would have just this, right? So like this, and you would have ID 2 and Zoe, right? So you would have 2 users like this. Then you would have another table where you would have addresses. And then you would have house number 123, road, foo, and so on and so on and so on. And same in here, 345 bar. Yeah. So you would have your addresses like this, you would have your users like that, and then you would have that third table, which would be user address map, for example, and you would have user ID 1, address ID 1, and user, well, actually let's just, so it looks a little bit more, user ID 2, address ID 1. Okay. So this will be your mapping between the user and the addresses. So now we have table of users, table of addresses, and in the third table we say we have all the mapping, so we know that address user 1 and address 2 belong together, user 2 and address 1 belong together, right? So this is the relational database. Now the document based, it would look like this. You would have users, and inside of the users you would have your ID and name. The ID is not necessary in document-based databases, but it's anyway, it's good to have it. You would have ID name, and then you would have addresses, and to user 1, address number 2 belongs. So here's this one. Right, and then you would have another user, and it has its own address. Okay. Oh, sorry, this one. Yeah. So as you can see, this is our relational database where every kind of object or entity is separated. While in document-based database, this would be one of our document. It has all the kind of information about that entity inside, and it has nested information inside of it as well. Right? Does it make sense?
Yeah, it does. And basically, I'm trying to think about which one is better, but actually it really depends on what you're trying to do.
Exactly, it really depends. So,
because if the address is coming from, I don't know, this Google thing where you just click and you have Google telling you what the address is, then I guess you're taking it from an API that's online.
Yeah.
I don't know. Sorry.
Exactly. So it really depends, and you will find that, I mean, if you do these kind of things, you will find that you like both of them will be applicable to a lot of tasks. So if somebody tells you want to solve this, you will say, well, you can do it with relational database like this and it has these advantages, and you can do it with document-based databases like this and it has different advantages. And again, especially for you, it shouldn't be up to you to decide which one, because these things have ginormous consequences, right? At the beginning of a project, I would almost go as far as to say that it doesn't really matter which one you choose. But once your project starts growing, once you start having thousands and millions of records and stuff like that, then it will really show which which is actually the better approach. Obviously, the way that you handle the data is slightly different, right? So, for example, if I want to assign a new address to a user, all I have to do is I have to create a new mapping in this table. I don't have to touch these two tables at all. While in here, I have to find the correct document, and I need to basically add it to these addresses. And then when I want to change the address, again, in the relational databases, I would just find it by ID and change its value, right? While in the document-based databases, I would have to find the object that address belongs to, and then change its value in there. Okay, and as you can imagine, it gets more complicated if you have objects that could belong to multiple documents, right, in document-based databases. So for example, if we, we keep talking about this books example, if we have something like this, where we have books, and inside of it we have document for every book, and it will be title, then it will be, for example, page count, and yeah, and then you could have authors, right? So authors, and one would be first name, last name, and then you would have the same in here. Right, so you would have two authors like this, and then you would have third one, which would be like a Jane, right, Jane Doe. So you have one book like this, then you have another book, which would be, whatever, page count would be 100, and this book was written only by John and Jane Doe. And then you would have another one where you would have, another book, and that one would be written only by Jane, right? So you have 3 books now, and you have their documents, basically, how they are described. Now, John and Jane are married, and they will get divorced, and Jane will get remarried or something like that. So Jane will change her last name, right? So now it's not going to be Jane Doe, but it's going to be Jane, Smith. So how do we do that? We would, in a document-based database, we would have to go through every single document in the system and check if that book has an author with that name and change it to Smith, right? So you would have to go through all of them and change it like this. Okay, so obviously, imagine if you have a bookshop and you have 1,000,000 books in there, you would have to go through 1,000,000 of records and change this to different value, right? That is the kind of problem clear there.
Yeah, it's very clear.
Yeah. If you imagine the same in relational databases, imagine that you would have your users would be authors, and then you would have authors assigned to the books. All you would have to do is to find that one single record of that author and change its name. So obviously, much simpler task, right? So that's what I'm saying when we talk about the difference between like which one to choose. You really need to be careful about which one to choose. Funny enough, this example would probably be something where people would turn to document-based databases, right? So for books, for example, you would probably want to use document-based databases because books are, the description of a book is basically kind of like an open article, right? An article is something that a lot of people actually use to describe the documents in document-based databases. They will tell you if it feels like an article, then it might be good for document-based databases. The other kind of pointer when to choose document-based databases is when you don't have a set structure of the data. So, for example, I would say that this book, the very important information about this book is that it has, CD included. Yes, right. So you actually get CD with this, right? But no other book you will get CD with. Now, I mean, I know that CDs are a little bit out, let's do USB. Right, so in this case, you can do that very easily, right? You can, in one object, in one document in the database, you can just say USB included, and that's it. If it would be a relational database, you would have to make sure that every book now has this value, right? So if we let's write it down in here as well with the books. So let's just copy this, put it in here. So this will be our authors. This would be books, let's say. Yeah. So this would be title. What else do we have there? Title, page count. Yeah, something like this. So right. So now we have I'm not going to change everything. So now we have this. So this is our relational database. Now, the way that it's modeled is a table, right? So you have a set of headers basically, and then data in it. So in our books, we could just say, well, we're now adding a head. We're now adding another header, which means basically column, to this data, and the data is going to be CD included. Right? So CD included. And when we do that, then everything has to have it, right? So you have to have this one is true and this one will be false. I'll just very quickly demonstrate it on Google Sheets, right? Right, so imagine that we have this data, which we have this table, which is our books table. So we would have ID, title, page count. Yeah. So this is our these are our headers. These are our columns that we actually have in the table, and then we would have 1, 2. Title would be Hello World.
Wouldn't you be able in the relationship database be able to create another table and say like other things and have in there the audiobook, for example, or the USB book, and then
yeah. So hold that thought because I will tell you about it. So this is the representation of what we had just had there. Now, obviously, visually, if you look at it, if I now add USB included, I just added this column, and by nature, all these records now have this column, right? So you would have to make sure that you actually fill it with data. Okay, so that's the kind of thing about relational databases, that you need to, you cannot shape the data individually. All the data will have to reflect the same thing. And it gets very complicated when you actually need to join things on these. So this could be a join to another table, right? And when you joining tables and there are no records for some of these records, then it gets, it gets quite complicated. So that's why a lot of people would use document-oriented database, where you just basically add whatever you want to the document. Now, the way to work around it, as Thomas said, yes, you could potentially create another table, which would be book meta. Usually it's called like metadata, right? Book meta. And what would that look like? That table would be a book ID, so you know which metadata that which book that belongs to. You would say key, and in here we would say use USB included, and value, true. Right. So now we have this metadata table where we're saying a book 1 the key for the metadata is USB included and the value is true. Okay, so we basically achieved pretty much the same thing. The only problem with this is though, well, there's many problems, but one problem with this is that this key is a free text, right? This key is not actually set anywhere. So you could end up with somebody saving a new data which would say CD included, right? Something like that. Or somebody could say, oh, actually, let's call it an asset. So you could end up with multiple things that means the same, that should mean the same thing, but have different keys. And in that case, you would not be able to query it properly. You would not be able to display the data properly because you would have to do a lot of exceptions in your code where you would just say, well, conditions, where you would just say if it's USB included or CD included or asset included, I want that value, right? So it's not actually set in stone, these names for that. The other thing is that you can't really expect what you get from this as well, like how many metadata and what else. So it's a bit, especially for the query size and stuff like that, it's a bit hard to handle basically. So, but that being said, these meta tables are being used quite heavily, right? Like especially if you have an older system that should be using document-based databases, or just generally people like to do that because it gives you the freedom, right? It gives you the freedom to put anything in there, and you don't even need to have this map table in the middle because this is basically already a map table. So you mapping between some kind of IDs and values, right? Another thing that I would say about this is you can go only so deep, right? So you're creating now one level, right? So basically what we did is this. What if I want to say now, let's say like what would I say? Sellers, right? And inside of those sellers, we would have name. Oh, actually, you don't even need to have objects, right? You can just do this. Amazon good books, etc. Whatever. So you would have a list of sellers like this. Now to represent that in here, it would be very hard because even if you could potentially add another keyword in here, but you can't really have an array in here anymore. So you have two options. One is either do it like a comma separated, so you could have something like this, but then you would have to remember in your code, think about how you use it in your code. You would have to remember that when you load this metadata, this needs to be split by comma, right? This needs to be split into an array. So in your code, you would have to then have, you would have to go through all the metadata. So you would just say for var I equals 1. Oh, sorry, I is less than meta length I plus plus, and then you would have to put some logic like this. You would have to say if meta key equals, yeah, let's leave it like this. If meta key equals sellers, then sellers equals book meta value split by comma, right? Something like this. So you would have to put this kind of logic to actually be able to handle this data somehow in your application. And again, going back to the original problem, if instead of sellers you want to rename it to publishers, then you need to change all the metas inside of this table with the keyword sellers to publishers, but also you need to change your code to say that this is publishers, right? Instead of sellers. So you're matching different key.
Yeah, so it gets messy.
Yeah, so it does get messy quite quickly. But yeah, metas are, they are being used for some reason anyway, for some good reasons sometimes. So it really depends on the choice of what to use. It depends on the kind of big picture of the application. Once again, you should definitely not be asked to do it. And honestly, even like a really experienced senior guys, if they will be faced with this question, it's just not that easy to do, right? Because especially when you have a early stage project, to be able to foresee all the information is just not that easy to do, basically. For that reason, I don't know if for better or worse, there are databases that actually have both systems. For example, PostgreSQL, they can do a relational databases and document-based data. They can do basically relational data and document-based data in one, right? So you install one database server and it can do both. When you save the data, you choose yourself if that particular data should be a relational or if it should be a document-based. After the rise of Mongo, where everybody started doing everything document-based, and there was a lot of issues with it eventually, Postgres actually, kind of gained a lot of popularity because of this kind of hybrid approach, and they're doing it really well, to be honest. I quite like it. So, yeah, so it's really up to you to choose the tools, or up to, well, architect mainly. So that's why there's no kind of easy answer to this, let's say. But this is going back to the actual what we're talking about today. This is what kind of document-based database looks like. Most, I would say, if not all, document-based databases are represented by JSON. So what you're looking at in here, this one record, this one document, is literally how it would be represented in the database, which is really nice as well, right? That's another really nice thing about document-based databases, that they are actually usually represented by JSON. So you can dump the whole JSON object in there and it will just save. Or you can load it as a JSON and you can just work with it very easily, rather than this kind of stuff, right? So it's in the age where we use JavaScript for a lot of things, this is very convenient, basically. When I said you can dump the whole object, if I have a books object, and if I have a books, let's say, table, and I put one book in there, and then the next object that I save in there will be something about dog. So you would say name of a dog would be, Chad, and the age would be 21, and type of dog would be, I don't know, husky, whatever. Right? So this would be perfectly valid data, right, in your database. So even though you probably by mistake you saved a document with a dog information into your books table, the system doesn't recognize it because it doesn't look at the data, right? And this is when those systems that we were talking about earlier, those kind of software layers, whatever they might be named, and however they might be represented, this is where they come to work. So instead of giving you kind of free reign over what happens in your application when you communicate with the database, they will kind of almost force you to define some kind of structure and give you an API to interact with the database, rather than doing it free text. So in your API, then you would say, books, create new, for example, and you would give it actually it won't be object. You would just say the title is hello world, and page count is 2, 3, 5, or 1, 2, 3. Yeah, so you would create the book like this. So there is no way that you could put the doc information in here, because this already would kind of force you to use a book object, right? Book structure. So that's why these kind of software layers come in to kind of help you not to make mistakes. Basically, they don't do as much else, but they just kind of help you to not to make mistakes. The one thing that I should say, we did TypeScript together, right? In these kind of cases where you do document databases and what I just showed you in here, it would be very handy to use TypeScript because you can actually define your interfaces. So you could say my interface book, right? And you would say the interface as title, string, and page count, 1, 2, 3, number, and authors, which would be, and then you would create another interface, author, and the author is as first name, string, last name, string, and then you would say that the authors is authors, list of authors, something like this. So you would define your interface like this, and then the TypeScript would actually do another check for you that you're not saving something that shouldn't be a book in your database. So TypeScript is very widely used with document-based databases.
Sorry, what is TypeScript?
Do you remember we had a lecture together on TypeScript when you were defining types on the functions and stuff like that?
Yeah, we've done so much that I can't remember. It rings a bell, but I can't remember it.
Yeah, don't worry, it will come back a couple of times, I'm sure. So basically, TypeScript is something that will help you to put some kind of structure and checks into your code, into your JavaScript code. So in TypeScript, you can say then, a books create new. So books create new equals function, and you would say title, which is a string, and number, page count, which is a number, something like this, right? So you could define.
Okay, so it forces you to have a title.
Exactly. So it will force you to do that. Or you could even say this, right? In this case, what we have already in here, we could say it will take the object of book, and the type of that is a book, right? Because we define our interface. So in that case, I don't have to pass it like this. I can just do my object as I would do in here. Let's say something like this, right? So I could do something like this, and then the function the TypeScript would actually scream at me if I put doc in here, doc information here. TypeScript would scream at me, this is not the correct information in there because you're expecting a book. So TypeScript is definitely quite useful with document-based databases. Let me just run through the here, so just so you know. So this is, I kind of showed you this already, is basically you have a JSON-like document. So the vocabulary, you have your table in SQL. It's called collection in document-based databases. And instead of rows as you have in SQL, you have documents. So each object is document. So in our case, books is the collection, and each object inside of each book, basically inside of it, is a document. And instead of columns, it's just called fields, like you would normally have in your object. Right. So document databases are efficient and effective for storing catalog information. For example, in an e-commerce application, different products usually have different numbers of attributes. So this is what I showed you, that if you have some kind of random data in different items, documented databases are pretty good at that. Managing thousands of attributes in relational databases is inefficient, and the reading performance is affected. Yes. Using a document database, each product's attributes can be described in a single document for easy management and a fast reading speed. changing the attributes of one product won't affect the others. So that is correct to a degree. The speed is very questionable because the speed, it really depends on your application. If you choose to use document-based document-based database for something that might not be the best fit, you might actually run out of your speed, run out of your performance very quickly. So you really need to be careful about it. But so you can do the other way around. So if you have a document that is really large, to do that in a relational database, like if you look at our example in here, we might have to do like 3 joins just to get the same data like we have in here. So in our document database, we would do 1 request to the database and we would say, give me this document. That's it. It would just give us everything. While in relation database, you would have to say, I want to load a book with ID 1, connect it with a book author map, which needs to also be connected with authors. And as an addition, give me all the records from book meta, right? From book meta. Or you would do this as a separate query. So suddenly, from just one simple request, you went into something that has many different joins, and then when you have like thousands and millions of data, it's just not that easy for database server to process, even though they are extremely efficient, and there are other things to mitigate that. It's quite difficult for databases to process them. Right, what do we have in here? So enter MongoDB. You can install MongoDB on your machine. Create a DB folder. That's basically where all the database stuff, all the data is going to be stored. And this is how you start your server. So Mongo, anybody can install it. It's pretty simple, and you can basically use it. What I would say is, and this is completely out of the scope of this, but what I would say is, whenever you install some piece of software on your machine, and especially if it's some kind of server-like thing, I would say try to explore other options how to install it, because in here, as it is written in here, when you install MongoDB on your computer, that's pretty much it. You are stuck with that MongoDB instance on your computer, and if you want to have 2 different projects with 2 different versions of Mongo, for example, then how are you going to do that? You can't just uninstall it and install it every time you use different project. So there are things, especially in virtualization, where you can have basically like containers or virtual machines on your local with different versions of stuff, and you can destroy them and start them very easily. So I would definitely recommend you to look at something like Docker or virtual machines, just to kind of avoid the issue of installing this on your machine and kind of being stuck with it. Or obviously you can use some kind of MongoDB cloud service, which there are countless. So you can use that as well. The code setup, you will install your MongoDB package, which is basically the library to use MongoDB, to connect to MongoDB, and do a basic setup. The basic setup includes connecting to the database, making sure that you have set the options correct, and that you handle any kind of database errors, and then selecting your database that you're working with. So we can try that now. I don't actually have MongoDB, so I'm gonna have to download it. I tried to do it through Docker, so let's see if it's actually running or not. So let's start with the video. Before I actually go into a code, does anybody have any questions before I go and geek out?
Not for me, no, thank you.
Yeah. Cool. So let's let me just save this in here for now, and we're gonna do npm init in here. So we'll start our npm project. Yep. I might have, let me just rename it just to make sure it's good. Something else. Right, npm install. What are we installing in here? MongoDB package. You can, if you want, you can do this, but you probably don't have the MongoDB as well anyway. So I'm installing the JavaScript library to interact with Mongo. Again, Mongo is not necessarily just JavaScript stuff, right? Like you can connect to Mongo with any other language, pretty much. And then we're gonna set up our project. So const MongoDB require MongoDB, and I will try nodemon in here as well. So nodemon index.js. Just see that. I will put clear in here. So you don't see all the other stuff. Right, so we require, as you can see, we require the MongoDB, and then we need to create a new Mongo client from MongoDB. So I don't know why this keeps happening to me. Const Mongo client from MongoDB. So we're basically just getting the Mongo client from the MongoDB. Okay. And then we need to connect to it. So, well, connection URL, let's just, I don't know why this is happening. Connection URL will be empty for now because we assume it's a localhost. And then we can do Mongo create, Mongo client connect, I think. Yeah. And connection URL. Some kind of options we can give it to. So in here we say retry writes and use unified topology. I'm not very sure what use unified topology is. We can have a look at the documentation. Retry writes basically means if you try to write something in the Mongo and there is an error, then retry it just to make sure that we actually have it in there. So we can do retry writes true. Let me just close this and put this in new lines just so it's a little bit more visible. And then we just have a callback with error and client. So what we do is we have our callback and we're gonna get either error or we're gonna get the information about the actual connection established. So in here we can say if we have error, then we didn't manage to connect. Otherwise, let's do the select database. So we'll do const db equals client db. I think that's what it is. Yeah. Let's just select coders. Oops. Right. So let's see what does it say in here. Invalid connection string. Okay. So let's try localhost 27017. See what that does. Invalid connection string. Mongo. Let's try that. It's still actually I'm not sure. Let me just stream this. Invite connection string, yeah. So okay, so let's see in the documentation what the connection string should be.
Sorry, maybe stupid question.
No, keep asking, please.
I mean, I was just fundamentally trying to. So far, we always use Node.js and use like a kind of db.json file where we put our database.
Yeah.
Locally, I guess. I'm just wondering, why do we need this? Like, is this because is there a way to actually have a database saved in a db.json file where you don't need to have all of this Mongo or MySQL stuff?
Yes, so you can, but then it wouldn't be necessarily persistent data, right? So, for example, if you imagine that this server that I have now in here is somewhere else than in my home, and then my home burns down, then that data is still on that server, right? It didn't burn with my computer, basically.
Okay, so yeah, back to your point. Having Mongo is kind of the gateway to a database saved on the server.
Well, the Mongo would be actually on the server. So the Mongo is what is storing your data. If that does it make sense?
So Mongo is actually on the server.
Yeah.
But the code you're writing, your index.js, is on your computer.
Yes.
So the code you're writing is actually to get access to the Mongo that is on the server.
Yes. So, so as you see this connection URL, right now I'm connecting to localhost, but this could be anything, right? This could be somewhere in cloud, somewhere completely else.
Oh, okay.
Makes sense.
Yeah. I think you can probably elaborate your question a little bit different, Thomas, because I don't think you're getting the right knowledge. I mean, you sound confused. Mongo is just a different kind of database compared to the previous one. Doesn't really matter where you store it. So you can have it, any of the databases, you can have it locally in your computer or locally in a server in your office or in the cloud. So the storage has nothing to do with the type of database. The where you store it doesn't have to do with whether it's Mongo or MySQL.
Yeah, no. My question was more, yeah, why? And I get the answer that it's actually because it gets you a persistent data. I was just wondering, because so far we always did our database locally and we didn't have to do all this coding to have Mongo or MySQL. That's why I was just...
Yeah, you were storing the information locally, just not in a database. It was just in a plain file, whether it is JSON or TXT or something. It was not actually in a database engine. Whether when it's in Mongo or MySQL, you're actually storing it in a database engine instead of just plain files.
But could you actually store your plain file in the server and make it persistent? Or do you always have to use a database?
Yeah, so imagine that you would do that. Imagine that you would actually store your file somewhere on the server. You would have to create some kind of script like you have in here to actually upload it to the server, right?
Because what you're doing now is uploading to the server.
Yeah, okay. I'm connecting to a server in here. So if you want to put your file somewhere on the server, you cannot you cannot just open file somewhere on the server and just keep writing to it. It would have to have some kind of interface to do that. So the interface would be either an API where you can just send it your text basically that you're writing, and it would be writing it on the server in that file, which is basically what databases do, but don't write it in the file, write it in something else. Or you could.
Like, could you do it with fetch, get, and
yes,
push?
yes, you could do that. Yeah. But if you do it with fetch and get and stuff, then you would basically the backend that you are fetching from or connecting to would have to have the logic to take that data and save it to the file locally. Yeah. And that's basically what the database does as well. You are making some kind of request to the database. On the background, if you look at it on much lower level, you're making requests to the database and you're saying, this is my query. And your query will be, I have this data and I want to save it, or I'm requesting this data. And it's basically like an API, right? If you think about it. And so what it actually does, that API, it will save the data somehow. Now, again, going to a low level of what databases do, the databases would actually take that data and write it into some kind of file on the disk. It wouldn't be a readable file. It would be some kind of encrypted and mushed file and stuff like that. Maybe binary, I don't know. But it will write it on a disk anyway, right? So the two things that database server needs is a CPU to do the computations, to actually execute your requests, and it needs the hard drive because data still takes space, right? So it will actually save the data somehow on a hard drive.
Right. Okay.
Yeah. So basically, you can replicate exactly what database does with just files, but you would have to have this kind of API. And if you want to do it yourself, in a sense that you would be writing it in the file, and then at some point you would say, now I want to commit it to somewhere in the cloud, you would have to take the whole file and upload it to that location. And to do that, you would have to write some kind of code. You would probably say like, fetch and do a post request with this file somewhere else. And then something on the other side would have to sit there and say, okay, I'm accepting this file and saving it into this storage, basically.
Got it. Okay.
Yeah. So it's funny because like if you think about it on a lower level, we think about everything on a quite high level, like databases and stuff like that. If you think about it on a lower level, it really is just some kind of API accepting your data and storing it somehow, right? Everything else around it is the kind of like a magic around it. Like SQL will let you store it only as a table, and it will make you, it has its own language how to get the data out, and it will make you do indexing and joins and stuff like that. While document-based databases have completely different things that you can do with it, and all these kind of things. So that's all kind of the sauce on top of it. But on the basic level, what it does, it will take your data and store it on a disk. Yeah. Well, obviously, doing a database as Ricardo said, is an engine. It has a lot of internal logic that you can use, while your file storage is just a static storage, right? You cannot run any logic in there. You just say, save this file now. That's it. You cannot do anything else with it. If you want to request it, if you want to get some data from file, you need to open the whole file, read it line by line, and find the data that you're looking for. So at that point, you're basically writing your own engine how to retrieve the data. While SQL and MongoDB and stuff like that, they have their own engines that do this for you, basically.
Got it. Okay. I think it needs
and you will need
iterations
to
until it gets into the head, but I feel like it's going on the right way.
Yeah. Sorry, Ricardo, what did you say?
No, I was just gonna add a little bit more to what you said, but seems like Thomas got it all now.
Well, yeah, it's a big word, got it all, but yeah, it's getting in the direction though.
This is not easy stuff to understand anyway for beginners. So don't worry about it. Like there's so much to this topic. Don't worry about it. As long as you understand that it's a storage for data, and basically the biggest advantage of it is persistent storage. Then that's all you need to know really for beginning.
Yeah, it's passionating. I quite like it. So.
How
Are
do
we
you,
going to do,
yeah.
are we going to do any practice or coding along on this, or this is just covered like theory classes?
So this one, let me just run you, because unfortunately we are almost at the end, but let me just run you through the slides, because it does have like a practice at the end, but we're not gonna have enough time to do it. But I will try my best to do at least something. So there is a free course from Mongo, so you can actually go to university.mongodb and they will kind of give you free course of how to use the database, how to use the engine. They will not tell you how to use it with JavaScript. They will just tell you how to query data, how to save it, and stuff like that. So basically, how to interact with the engine. And then this is the practice. So the practice is create API using MongoDB and Express, and we will have a couple of endpoints, and it should do something. So if you have a doctor's endpoint, when you have get, it will get all the doctors. If you do post, it will add a new doctor and the patients and so on and so on. And yeah, that's pretty much it. Then Mongoose, I just want to show you this because this is basically what we were talking about at the beginning. Mongoose is a well, I will just read it to you. Mongoose provides a straightforward schema-based solution to model your application data. It includes built-in typecasting, validation, query building, business logic hooks, and more out of the box. So this is exactly what we were talking about with the SQL and their kind of setup. This is pretty much the same thing. So what do you do? Oh, that's it. So what do you do in Mongoose? Mongoose is a library for MongoDB interaction, and you just say, I'm defining my model, which is the cut, and it will have this kind of model, and then you can create your objects basically and save them. If you look at this kind of kitty.save and then and so on, that's not by default in JavaScript or in Mongo. This is the Mongoose library that you can use basically. This is up to you to use it or not. Just because it's there doesn't mean that you have to use it. We talked about this before as well. Choose your libraries very wisely. Make sure that you actually need them for your project. So that's the Mongo, and I think, I don't know why this is not going away, but yeah, so this is the last slide pretty much. So we can now go back to practice and just try at least quickly do something. I have it here, yeah. So now we are connected, as you can see, connected. So we are connected to the MongoDB. Now we also need our Express, right? So let's install our Express. And we can create new Express application as well. So we would do const Express. And up the Express, I think. Right, and now in here we would say, let's just move this all down a little bit, and we would say up this on 3666. Okay, so now we should be able to go here and do localhost 2666. Yeah, cool. So now we have our application running. So the first requirement was to create an endpoint with doctors. So we can say up get doctors. Request response. And return all doctors. Okay. So we will do res send doctors. Okay, so now in this case we should be able to say /doctors, and you will see that we have empty array. Okay, so now we need to actually load these doctors from a database, right? So in here, what we want to do is we want to load the doctors from database. Now you can see that we have connected in here, and we have this database. We will move this database up in here just so we can use it elsewhere. So we would say let db, and then in here we would just assign it. Right. And then in here, we'd say db, and then we can somehow request the data. So let's have a look at how we request data from Mongo. What kind of interface they have, right? So documentation, and in here you can say, I guess API. We can go to collection. Okay, so our doctor collection would be doctor collection. So we will do doctor collection, doctors, and then we can just do find like this. So you actually find something in there. So unfortunately, it looks like it doesn't support promises, but let's see if it does. No. So we will do collection, find, and you probably would give it empty array. This empty object. This object is basically your filtering, so you can filter what you want to actually find. So in here we should be able to say console log, and then if we make a request, let me just move this here so we can see it easier. So now we requested it, and you can see in here we're getting all sorts of stuff. So we're getting the cursor. So it's basically like the position at where you are at the database. So in here they say to array. So let's do to array, where you're basically converting the data to something readable in JavaScript. And apparently it takes a callback with error and
the to array, is that JavaScript or a Mongo feature?
This is a JavaScript, but you know it's a method implemented on the collection, right? So it's the MongoDB library has this to array defined somehow in there to do something.
Yeah, okay. Oh yeah, JavaScript is the whole backbone of the whole thing.
Yeah.
So it wouldn't work if you didn't have Mongo.
This one wouldn't. No, it's a valid JavaScript, but this method is defined in MongoDB library. Yep. So yeah.
Okay, got
it. Now we can do this, and we should be able to do console log doctors. So now in here, you will see that we have empty array. So now we are at the point where we're actually loading all the doctors. So what we can do is we can just send the doctors back, right? And this is our first request. So this is our first request. What we did is we connected to a collection of doctors. So we not really connected, we selected the collection of doctors.
And where did you create that collection?
you don't have to create it specifically. It's just if you actually request something from the collection, it will create it basically. It's something that doesn't necessarily have to be created. If it's not there, it will just create it. It's not gonna error out.
Okay.
And then in collection we say find, and this empty object means I don't want to filter anyhow. And then we're saying I want to convert it into an array. So basically what we're saying is, we want to use it in JavaScript as like a normal way. Error is something went wrong, so we could put like an error check in here, and if not, we will get our doctors and we will send them back to the actual view where we called it from. So that's
in the find where you said that we are not sending any filter.
Yeah.
That will be where you put some sort of parameters like last name Rodriguez,
yes.
for example.
Yes.
You will put that in there as a filter.
Yeah.
And you will get that from a parameter in the URL.
Well, you could if you wanted to. Yeah, you could.
Okay.
So now the next requirement was if we do a I don't have it anymore. Here, if we do post, so add a new doctor. So we will say, okay, add post doctors request response, right? And again, we will select our collection of doctors. You can do this centrally somewhere. I'm just doing it now in here, but you could do it centrally somewhere. And we will say a collection insert. I think it is insert. I'm not sure, but I think it is.
This is a lot simpler than dealing with MySQL stuff.
Well, it will get more complicated as you will try to do like a relational stuff and things like that. But yeah. This also, why you might be thinking it's simpler, because you don't have any like mongoose and stuff like that in your way. You're basically interacting just directly with the database, but obviously that has some drawbacks because it could be inconsistent or something like that. So, basic examples are definitely very simple. Yeah, you don't have any kind of because in as you know in MySQL you would have to do something like. You will have to do something like select everything from doctors, and then you would have your where, right, to filter and so on and so on. So it would be kind of and then you need to run the query and collect it and stuff. So yeah, this seems a little bit more native, and it's only because it was kind of meant to be interacting with JavaScript, so that's why it feels easier.
Yeah, and you will get an error, for example, if the table does not exist, whether here you're just creating it right away just by invoking it.
Yeah.
It's just different.
Which is, is a good thing. Like, because if you make a typo, if I say just doctor instead of doctors, then you might want to, you might actually want it to tell you something is wrong. So, don't know. So we inserting something inside, or actually we should be getting this really from the request. So we can just say request, and I think it's body. And then once it's inserted, if it's inserted correctly, there will be definitely again error result. And then we will say if error. I'm not gonna make it too sophisticated right now, but at least so you see something. So yeah, I guess. Okay. So now we have this. We inserting the body that we send it to, and we will see the result. So let's see if that actually works, because I'm not sure if it's gonna work. So let's see. I'll open Postman because it's easier than through browser. If I wanted to do it through browser, I would have to actually write like a fetch function and stuff. So we don't want to do that now. So doctors, you will see we are getting nothing. If I go and create a new one, doctors, and it will be a post, and the body will be a this content length. Oh no, yeah, of course. Right, so body will be first name, and last name, something like this. So now if I send it, we will get type error. Let's see if we get something from in here. Yep. Cannot read ID of undefined. So there should be an ID as well. So let's just do of undefined. Oh, okay. So let me just do ID1 for now.
Why underscore before the ID? Is it just
it's a Mongo thing, really.
Okay.
But it is a good question. I think they struggled with that a little bit as well. But it's just because it's reserved, you can't really change. Like every object should have it, you can't really change that. Well, I'm actually surprised that it asks us to add it, because it should be by, if you don't put it in there, it should be by default. But it might be just in Mongo. So I don't really remember. I didn't do Mongo for a while. So we have this, and let's just log out the request body, because I'm not sure if that's actually what it is, body. So if we send this, that might have actually worked. No, it's undefined.
Undefined. So you don't have a request body.
My brain is not working anymore.
Do you need to put result actually? So if you look at the last line,
on the
result sends, it's just blank.
Yeah, I mean the result. I mean, in this case, because we insert it in the database, you don't really. There is not much to send back, really. Let's say, because you just inserted it. But yeah, you could kind of decide to send something back. It depends on the actual input. No, there should be body.
Success or something. Yeah.
Oh, I should probably use this as well. Right. Just to make sure that it's actually parsing JSON when it receives JSON. Let's see if that works. Error. And it said it's still gonna read undefined. Do I still have my request body in there? I think it might be because I need to add the header for JSON. There you go. No. We have some other console logs somewhere, do we?
If you do just request rather than request body, is it still undefined for the console log?
I don't actually see it there now for some reason. Or is it this whole thing is a body? No, it's not a body. This is that's the cursor. Yeah, that's the name. Oh, there it is, body. That should actually, oh, maybe, has it worked already?
So it works actually.
It's still showing me error. Right.
Can't read property ID of undefined. It's because you need to put ID and then on the brackets request body, or no?
This should definitely not be. I'm actually stumped a little bit because this should not be asking me for that. This should be just request body. Don't know why it's asking for ID. Oh. Did that actually happen? Oh, that might be actually okay. So now, I think now it was successful. So if you do the get, right? So now we have it, right? So we saved the doctor and we requested it back. Obviously, this one, that's why it was, because it was trying to enter something with the same ID, which is, bad, obviously. But so this one is messed up, but the other ones are fine. So now if we save new one, if we say Zoida style, then if we get again, we should get her as well. So now we can basically, now we have working an API where we can save the doctors and request them back in an array, right?
Nice.
So that's how it looks like. I mean, it's not pretty, but that's how it looks like. So really two simple commands. One is finding all of them, and one is actually inserting into the collection. You could, I'm pretty sure that with this you could basically do the rest stuff. So you can do patients, right? And then you can get all the patients from doctor's ID, let's say. So you could, yeah. Could do as well. Cool. Any questions? Because we are going over time and don't want to keep you too long.
No, thank you. It was very helpful.
Yeah, all good in my end. Thank you so much.
Yeah. How, Christina? Do you understand? Do you understand it?
Little bit.
Little bit. Good. That's better than at the beginning.
Yeah, thank you.
Okay, cool. Well, again, if you have any questions, just ping me on Slack and let me know. And yeah, you can always ask Vasil if this is actually going to be used in any of your exercises. Cool. Well, thank you for listening.
Thank you, Thomas. Thank you.
Thank you. Bye.
Bye.
Bye-bye.
Bye-bye.